Hi guys, in this video we're going to look at how we can solve linear and nonlinear simultaneous equations. So to do this we need to rearrange our linear equation so that it's in terms of x or y, substitute that into our nonlinear equation, expand our brackets and factorize to find our two values of x, and then substitute our values for x into our equation to find our values of y. Okay, that seems like a lot of information. Let's try it with an example. So we're given two equations, x minus y plus 8 is equal to 0, and x squared plus xy plus 8 is equal to 0. In this case, we want to solve for x and y. The problem is, if you have two unknown letters in an equation, you cannot solve for it. You can only solve for simple equations that only have one letter. For example, 2x is equal to 8. We know that therefore x is equal to 4. If you have one unknown, you can solve for it. But if I have two unknowns like this, x plus y is equal to 8, I can't solve for either of those letters. So when you're solving a simultaneous equation, what you're trying to do is eliminate one of the letters in your equation. Okay, let's look at this first example. So we have x minus y plus 8 is equal to 0, and x squared plus xy plus 8 is equal to 0. The first thing we're going to do is identify which equation is linear and which is nonlinear. Your linear equation will only have x and y values with a power of 1 on them. So the highest power on those values will be 1. A nonlinear equation is the one in blue. This is nonlinear because it has an x value that has a power higher than 1, that's x squared, and one of your terms is two variables multiplied together, that's x times y. So the first thing you do when trying to solve for this is take your linear equation. So that's x minus y plus 8 is equal to 0. And rearrange it so that you have x or y as the subject. That means you're going to rewrite this so that you know what x is equal to in terms of everything else in the equation. Keep x on one side of the equation and move everything else to the other side. That leaves you with y minus 8. This means that x, everywhere I see x, it's the same as writing y minus 8. So those two mean the same thing. And now I'm going to use that information to write my nonlinear equation in terms of y. So wherever I see x in my nonlinear equation, I can now write y minus 8 because they mean the same thing. So we're going to substitute the linear equation into your nonlinear. So here's my nonlinear. And we're going to substitute in y minus 8 wherever I see x. This leaves me with y minus 8 squared plus y times y minus 8 plus 8 is equal to 0. And we can do this because we've just said that x is the same as y minus 8. So they mean the exact same thing. And now what have we got? Well, now I have an equation that only has one letter in it. And once we have one letter in it, then we can just solve it by using our normal factorizing methods. Okay, so now that I only have one letter, I just need to prepare my equation for factorizing so I can solve for y. That means we're going to first expand our brackets. Okay, so we're going to multiply out these brackets. So this gives me, I'll actually just do this underneath here so we can see it a bit better. Okay, so I'm just expanding the brackets now. So this gives me y minus 8 times y minus 8 plus y times y gives me y squared. Y times minus 8 gives me minus 8y plus 8 is equal to 0. Okay, let's keep expanding those brackets. So y minus 8 times y minus 8 gives me y times y gives me y squared. Y times minus 8 gives me minus 8y. Minus 8y gives me minus 8y. Minus 8 times minus 8 gives me plus 64. That's plus y squared minus 8y plus 8 is equal to 0. Okay, so we're just adding together. So now that we've expanded all of our brackets, we're just going to add together our like terms here. Okay, so I've expanded all the brackets and I'm just going to tidy it up by adding together our like terms. Okay, so that gives me y squared plus y squared gives me 2y squared minus 8y minus 8y gives me minus 16y minus 8y gives me minus 24y. And then 64 plus 8, that's 64 plus 8 gives me plus 72. So now my equation is 2y squared minus 24y plus 72 is equal to 0. So to solve for any quadratic equation, you just need to factorize it and solve for your values of y, or you can use your quadratic formula. In my case, I'm going to factorize it using team. So when we're factorizing, the first thing we can do is simplify our equation. This means we're going to divide everything by the common factor. So in our case, everything here is divisible by 2, so I'm going to divide everything by 2. This leaves me with y squared minus 12y plus 36 is equal to 0. And to factorize this using team, we're going to see what values times to make the end and add to make the middle. So what are the factors of 36 that can add to make minus 12? So our factors are 36 times 1, 18 times 2, 12 times 3, 9 times 4, and 6 times 6. So we want what factors can add to make minus 12y, and that's 6 times 6. Okay, so that's minus 6 times minus 6 gives me 36. Minus 6 plus minus 6 gives me minus 12. We draw out our two brackets, which leaves me with a y in both brackets and the factors of 36 in both brackets as well. This leaves me with y minus 6 is equal to 0. Okay, so now we're going to solve for our two values of x. So to solve for our two values of x, we're going to take both brackets that we factorized and put them equal to 0. That's y minus 6 is equal to 0 and y minus 6 is equal to 0. This leaves me with y is equal to 6, or in this case, y is equal to 6. So in this case, we only have one value for y, and that's 6. Okay, and we're not fully done yet. So from here, we now need to find our corresponding value of x. So we find in our equation what is y equal to, but now we need to find what is x equal to. To do this, we're going to substitute our value for y into our linear equation. So our linear equation was x is equal to y minus 8. To find what x is, wherever I see y, I substitute in 6. This leaves me with 6 minus 8. So x is equal to minus 2. That means your coordinates, or your answer, is minus 2, 6. And that's your final answer. Okay, I hope this video helped. Thank you.